Hello, and welcome. In this video, we'll showcase how to build and test a lightweight project using Oracle Cloud Infrastructure Functions, integrated with Macha libraries. While Macha libraries support multi-cloud setups for business flexibility, Oracle Cloud Infrastructure stands out with its high performance, cost efficiency, and seamless enterprise integration, making it a robust choice for scaling serverless solutions. Let's dive in, explore the tools, and begin building efficiently. Before we start building with Oracle Cloud Infrastructure, let's set up your access. If you don't already have an account, Oracle offers a free tier that includes always free services and credits to explore advanced features. To create your free account, visit oracle.com/cloud/free. Fill out the registration form with your details. Verify your email and payment information for service activation. The free tier gives you access to OCI Functions, compute, object storage, and more, perfect for testing and deploying versatile Macha projects. Once your free account is ready, log into the OCI console, and you'll be ready to proceed with building and testing your first MachaOn project. Since I already have my Oracle Cloud Infrastructure account set up, let's move to the next important step, downloading the MachaOn project. To get started, we'll access the project's repository, which contains all the necessary files and configurations for this demonstration. Once we've located the repository, we'll download the project to our local environment for further customization and testing. With the project downloaded, we're ready to proceed to the setup process and begin integrating it with OCI Functions. Now that the MachaOn project is downloaded, let's move to opening the Oracle Cloud Infrastructure console. For this, I'll use Anteater, a lightweight utility designed to streamline the development process. Once the OCI console is open, we'll move on to configuring the environment and setting up everything required for deploying the MachaOn project. Before we proceed, we need to authenticate the OCI CLI to allow it to securely interact with Oracle Cloud Services. To do this, we'll start by running the authentication process. This will open a browser window where you'll log into your OCI account and verify your credentials. Once authenticated, the session will be active, allowing the CLI to manage resources seamlessly. For more details or troubleshooting, you can always refer to Oracle's OCI CLI Quick Start Guide. To deploy an OCI function, the code is packaged and deployed as a Docker image. This involves preparing and pushing the image to the Oracle Container Registry. The first step is logging into OCIR. OCI requires Docker authentication before pushing images. You'll need two key pieces of information: your tenancy namespace, which you can find on the tenancy page in the OCI console. An auth token, which acts as a secure password for this login process. With these credentials, authenticate by running the login command for your OCI region. Provide your namespace, username, and auth token. Once logged in, you'll be ready to build and push your Docker image to OCIR, ensuring it's accessible for deployment as an OCI function. Now that we're authenticated with the OCI Container Registry, let's move on to building the Docker image for our function. In this project, we're using a custom Docker image, so a Docker file has been created and the func.yaml file has been configured to align with the application's requirements. To streamline the image building process, we'll use the fn project by running the fn build command. This automates the creation, configuration, and packaging of the Docker image for deployment. Alternatively, if you prefer, you can manually build the image using Docker commands, but for this demonstration, we'll focus on the fn build workflow to save time and reduce complexity. Once the build is complete, we'll have our packaged Docker image ready for pushing to the OCI Container Registry. Now that the Docker image has been successfully built using the fn build command, let's take a look at the results. In the Docker environment, you'll see the newly created image listed along with its corresponding tag. This image has been packaged according to the configuration in the Docker file and func.yaml file, making it optimized and ready for deployment. With the Docker image built, the next step is to push it to the Oracle Container Registry, OCIR. This step stores the image in a secure, centralized location, making it accessible for deployment and collaboration with other developers or CI/CD pipelines. To push the image, we use the Docker push command, specifying the region key, tenancy namespace, repository name, and a version tag. For example, in the Frankfurt region, the command would look like this: Docker push EU, Frankfurt, 1.ocir.io/tenancy namespace /repository name tag. Alternatively, you can streamline this process using the fn project. By running the fn deploy command, you both push the image to OCIR and deploy the function in one step. For this, you specify the application name in OCI and the target container registry. For this presentation, I'll demonstrate a manual push using Docker's docker push command. Once the Docker image push is complete, let's verify the result in the OCI Container Registry, OCIR. We'll navigate to the OCI console and open the Container Registry section. Here, you can locate the repository where the image was pushed. The list will display the image name, version tag, and other details, confirming that our image has been successfully uploaded and is ready for deployment. This step ensures that the image is stored securely in OCI and accessible for use in your applications. Now that we've verified it, let's move forward to deploying the image as an OCI function. Before deploying a function in Oracle Cloud Infrastructure, we first need to create an application. OCI applications act as containers for functions and define important resources, including networking and logging configurations, essential for function execution. There are two ways to create an application, using the OCI console or the OCI CLI. For this presentation, we'll be using the OCI console for a streamlined and visual approach. Let's navigate to the Oracle Functions section in the OCI console, create our application, and configure the necessary details to prepare for function deployment. Before creating an OCI function, we need to configure environment variables to securely pass runtime settings and sensitive information, such as credentials, API keys, or secret values. These variables ensure the function has the necessary configurations for execution without exposing sensitive data in the code or logs. For this specific function, which integrates with Commercetools, we need to define the client secret as an environment variable. This value allows the function to authenticate and interact with the Commercetools API securely. Now it's time to create the OCI function, which will be deployed as part of our application in the Oracle Functions service. Before we proceed, ensure the OCI CLI is authenticated. If the authentication method isn't set, use the following command to securely authenticate with a security token. Set OCI_CLI_AUTH equals security_token. Next, we use the OCFN function create command to deploy the function. This command references the application ID, the Docker image hosted in OCIR, and memory allocation for the function. For example, in this case, we execute. Specify the application ID where the function resides. Set the display name of the function. Provide the path to the Docker image in OCIR. Allocate memory, in this example, 128 megabytes. With the OCI function creation complete, let's confirm that it was successfully deployed by checking in the OCI console. Navigate to the Oracle Functions section within the console and open the application where the function was deployed. You'll find the newly created function listed, along with essential details such as its name, lifecycle state, memory allocation, and invoke endpoint. Verifying the function in the console ensures it's active and ready for execution, allowing us to proceed confidently to testing its integration and runtime behavior. With the function successfully deployed and verified, the next step is to invoke it directly using the OCI CLI. We use the OCFN function invoke command, which lets us interact with the function by passing input payloads and receiving output responses. This ensures the function executes as expected. To invoke the function, specify three key parameters: the function ID, OCID, of the function created; the payload, which could be any data required by the function for processing; an optional output file to store the result, or dash for standard output, stdout. For example, we provide an existed Commercetools customer ID as a payload and the function responds with structured data such as the user's profile, confirming its successful integration and execution. Once invoked, we can review the output and validate the function's behavior. If everything runs smoothly, the OCI function is now fully operational and ready for use. To complete the validation process, let's open the Commercetools Merchant Center and locate the user specified in the function's response. By navigating to the User section in the Merchant Center, use the user ID or email address from the function's output to search for the requested user profile. This allows us to confirm that the function successfully interacted with the Commercetools API and retrieved accurate data. Validating the result ensures end-to-end functionality and confirms that the integration is working as intended. With this step complete, we can confidently consider our function deployment and integration successfully verified. Logging is a critical part of managing and debugging OCI functions. It allows us to monitor function behavior by capturing standard output, STOUT, and error messages, STER, during execution. Oracle Cloud Infrastructure integrates with the OCI Logging service, making it easy to collect, store, and analyze logs for improved visibility and debugging. Let's configure logging for our function application via the OCI console. First, navigate to the Functions section in Developer Services and select the application associated with your function. On the Application Details page, locate the Logging section. If logging isn't enabled, you'll see an option to enable logging. Once enabled, OCI will collect logs for all functions within this application and store them securely in the specified log group. Logs are fully encrypted at rest and in transit, ensuring both security and reliability. To view the logs, go to the OCI Logging service in the console under Observability and Management Logging Log Groups. Select the log group specified during configuration. Locate the log name associated with your function. Using the OCI Logs viewer, analyze logs with timestamps for function output messages, errors, or debugging information. You can also use advanced query and filtering tools built into the Logs viewer to isolate specific events, such as error messages or custom log entries. This helps streamline your investigation or monitoring process. Finally, if logging is no longer needed, it can be disabled at the application level from the same logging section. Thank you for watching. If you have any questions or feedback, feel free to reach out. Don't forget to like, share, and subscribe for more tutorials and updates. See you next time.